Good day, class. You are welcome to week 3 and you are also welcome to lesson 1 of today's topic. And the topic for today is data collection and presentation. Data collection and presentation. When you talk of data, what do you understand by the word data? Data is a collection of facts such as numbers, words, measurements, even descriptions of things. In example, you will always hear sometimes the population census they are taking, they want to do counting. All these will refer to all the data, all the analysis of numbers they are able to gather, maybe in a family of 4, a family of 5, we have this, we have that. All this will refer to them as data. And there are sometimes we have raw data, the data that have not yet been worked on. So data can be represented in terms of frequency. You can use frequency tables to represent your data. You can use pictograms, you can use bar charts, you can use pie charts, you can use line graph. You can use all these to represent your data if you don't want to be mentioning it one after the other. Alright, frequency table can be constructed from the set of raw data and draw graphs to represent such information. Let's move on. Let's look at this data given to us. Example 1, given a set of numbers 1, 3, 2, 1, 4, 2, 3, 2, 2, 4, 1, 4, 2, 2. Number 1 occurs 3 times. Number 2 occurs 6 times. Number 3 occurs 2 times. Number 4 occurs 3 times. That means we can represent all these on our frequency table, which means 1, 2, 3, 4. These are the number of their occurrence. Example 2. A die was tossed 20 times, and the number of times each number occurred was recorded. So, of the 20 times, 6 appear how many times? How many times did you see 2? How many times does 3 appear? How many times does 4 appear? How many times does 1 appear? There is no 0 there. No, they would have included 0. So now these are the faces of the die. So how many times do you have the occurrence of all this number? So let's look at this. It will be good you have this. If you move to the table, the frequency table, it will be good you have it on the table. It is very easy for you. So now if you look at 6, how many times do you have 6? We have 1, 2, this is another 6, 2, this is another 6, 3. Here the number of times 6 occur is what? Is 3 times. Can you see? The first A is 3 times. Let's look at the second one. How many times did 3 occur? Count the number of 3 you can see here. We have 1, 2, 3, 4, 5, this is fifth one, 6. It occurs 6 times. Can you see it? How many times do you have 4? We have 1, this is another one, 2, 3. It occurred 3 times. So 4 occur 3 times. Which number occur most frequency? If you look at this very well, which one has the highest number of occurrence? That is what? 3. You can count the number of times it appears. You see that it's more than the other number because it appears 6 times. So out of 20, you already have 6 of its occurrence. Which number has the least number of occurrence? Check it out. 1 appears 3 times. How many times do you have 2? This is 1, 2, 3. It appeared 2 times. How many times did you have 3? 1, 2, 3, 4, 5, 6. 4, 1. We have 1, 2, 3. We have 3 or 4. How many times do you have 5? 1, 2. So if you look at all the numbers I've counted, you see there is only 5 that appear twice. So it has the least number of occurrence. Can you see? These are the values. So this is an assignment 1. Is on page 287 of your new concept mathematics. So attempt number 3, 4, and 6 and submit it to the required mail. Now let's look at the data presentation. We present our data so many form. You can arrange it in increasing order. You can arrange it in decreasing order. Or what we know, it can be in any form of rank. So example of this will be represented either by finding the highest score, lowest score, and so on. So let's look at this example. Arrange the following scores in ascending order of magnitude. That is, you want to arrange it in ascending order, moving from the smallest to the highest. That is the meaning of ascending. When you say descending, it means it's moving from the higher to the lower value. So let's look at how we can arrange all the number 0, 1, 1, 0. You arrange it. 0 comes first, followed by 1, followed by another 1. This is my 1. Sorry. Followed by what? 4, 5, 6, 12, 17, 18. So this is the arrangement, ascending order of magnitude from 0 to 18. The highest score here is 18. Can you see it? That's the highest. And the lowest score is 0. So the number of score above 6 is what? How many number do you have after 6? After 6 here I have 12, 17, and 18. So I have 3 scores. After what? After or 3 score above 6, 12, 17, and 18. With this example, I have given you another assignment on page 290. It's the same thing with this one. So you attempt number 1 and 2 of exercise 22.2. Alright, let's move on to frequency distribution table. When data is first collected without being processed, we refer to it as raw data. I made mention of that initially. A data you have not yet worked on, you just gather it. Maybe the number of women that gave birth at general hospital, the raw data, either twins, triplets, one, and so on. All these are raw data that have not yet been worked upon, so you can gather it so many form. So the data that have not yet been worked upon is what we call raw data. It is also data. Or when we talk of frequency, is the number of times a particular number occur in a given set of data. The number of times it occurs, the number of occurrence, we refer to it as frequency. We also have a frequency table. When you tabulate your given set of data, it corresponds the frequency to the score and so on. So we refer to it as frequency table. Here is an example of frequency table. So we have number, we have frequency. So how many times does 1 occur? It occurs 3 times. How many times does 2 occur? It occurs 6 times. How many times do you have 3? Twice. How many times do you have 4? Twice. So this is an example of what? Frequency table. Let's move on. Use of tally. Actually, we are going to draw table. So we are looking at what our table will be made of. So we know that tally also will be presented on the table. So the tally is stroke or mark used to represent the numbers or the times each score appears. So let's look at this. By the time you have 5, you want to have tally of 5. From here we have 4 line. The 5th one is used to cross it. So where you have 3, there is 3. If you have 4, it will be 1, 1, 1, 1 in 4 places. and if it's 5, you have 4 stroke and cross it with 1. So let's look at this example now. So all those examples we have been looking at before, we did not make a frequency table. So here we are going to draw frequency distribution to display and even see how easier it will be to solve with the table. Example 4, consider the scores of 20 students in GSS 1. Is given as this: 11, 10, 12, 11, 11, 12, 12, 12, 10, 10, 10, so on. So draw a frequency distribution table to display the data. Name what is the highest score? What was the lowest score? How many students score more than 10 marks? Find the percentage of students that score above 12 marks. The first question is to draw the frequency table. So let's see how we can take this into frequency table. Let's consider the scores and the number of students that had the score. Alright, for 10, how many students? 7 students, and that is the frequency. For 11 score, how many students had 11? 4. How many students had 12? 7. How many students had 13? 2. So if you add all the frequency together, it makes 20. You must make sure that your frequency equals to this number, not total number of students, because sometimes you might make mistake by omitting 1 or 2 number. So you cross check by your frequency that is it equal to the total frequency made mention of initially, which is 20 students. Alright, we have already constructed our distribution table. We've drawn that. So what was the highest score? From the score here, we have 10 to 13. The highest score here is 13. Are you with me? So if they ask for the highest score here is what? 13. Let me show you the answer. The highest score was what? 13. So what was the lowest score? Look at it from your table here. The lowest score here is 10, which is the answer here. How many students score more than 10 marks? This is 10 marks, and 7 out of 20 had 10 marks. That means the remaining student had more than 10. So you add up 4 plus 7 plus 2. 4 plus 7 is 11, plus 2, it gives you 13. So 13 students score more than 10 marks. The last question, find the percentage of students that score above 12 marks. How many students score above 12 marks? The number that is above 12 marks is 13, and it was only 2 students that score above 12 marks. That will be 2 over the total frequency times 100. Look at it here. Then you multiply that, you have 10%. That means 10% scored above 12 marks. Okay. So here is another assignment for you. Please try as much as possible, do it and submit it to the required mail. Welcome to lesson 2. Data presentation. How can you then present your data? You can present your data in so many forms. That is, how will you display it? After when you have collated all your data, how will you make it meaningful for people to view and should be able to interpret all your data? We have the pictogram. It can be in form of a picture. We have the bar chart in form of your bars. We have the line graph. We have the pie chart or a circular graph. And we have the histogram. So these are the ways by which you can represent your data. The first one we are starting with is the pictorial representation of data. The pictorial representation can be called picture graph or ideograph. Let's look at an example of this. The enrollment of students to GSS 1 class in Scholar Universal School between 2006 and 2010 are shown below. So let's look at the enrollment. For this year, these are the number of students that was enrolled. So now, for 2006, we have 50 students being enrolled. For 2007, we have 400 students being enrolled. 2008, we have 150 students being enrolled. 2009, 200 students being enrolled. And 2010, 250 students being enrolled. Alright, So to make it easy, there is no way I will continue to draw this for like 50 times, 100 times, 250 times. It would make no sense. So now let's just scale it up, or we scale it down. So let each picture be equal to what? 50 students in GSS 1. So where I see 50, it will be one picture that I will have there. So for 2007, where I have 100 students, it will be just two picture. Are you with me? Because 2 times 50 is 100, 3 times 50, 150, 4 times 50, 200, and 5 times 50, 250. So this is how I represented this on my pictogram. So this is just an illustration of a pictogram representation. Bar chart. Rectangular bar blocks or columns are used to represent data on bar charts. So the bar charts usually have the same width and equal space between them. For the bar chart, you make sure that the width must be the same. You just don't draw it anyhow. You look at the width and you make sure you draw it to scale. Example 2. The number of students in a school who play football, hockey, basketball, and table tennis are shown below. So here we have different types of games, and we have the number of students that participated. So we have to represent this on a bar chart. So here is my frequency, and here I have different types of games. Alright, I have been told that the number of students range from 70 to 140. So that is why I calibrated my frequency from 0 to what? To 160. I assume 1 centimeter to be equal to 20 players on the vertical axis. Not that you will write 10 here and you start the next one by 30, 70. No, you can't say because 40 has been given to you here and you will start to, okay, you can't say because you have 50 here, oh, I do not have 40, just let me start from 50. No, you will not be able to read up your value because you do not have a, what should I call this, your scale is not the same. If you write 50 here, at the end of the day you went ahead and go and put 80 here, what will now, and the next one will be 120. What are you then saying? You have not really actually have a unique scale. You must make sure that your scale is either ascending with a definite amount or distance. If you look at the difference between 20 and 40 is 20. Difference between 40 and 60 is what? Is 20. And difference between 60 and 80 is 20. You can see that the trends increase by what? By 20. So draw it to scale. That's why I put 1 centimeter to represent 20 players. So here is your frequency. You have your games here. So for football, so for the football, it is what? It is 140. Can you see? Sorry. So you have this. For hockey, 80, basketball, and so on. So this is how, just draw, use your pencil and your ruler and draw it to scale. It's so simple. You can use your graph. You can use the scale on your graph. You can draw it on your graph. You know that one is calibrated. So as this we might give you a lot of stress, you can make use of graph to draw it. Look at your scale. Just assume 1 centimeter to be equal to 20 players, and from there you look at the table. Come back to your table. For tennis, 70, you draw it. For basketball, you trace it. You trace your basketball to where 50 is. You draw your table. So that is all about bar chart. So let's move on to pie chart. This pie chart is a circular graph and is divided into sectors such that the angle at the center is proportional to the frequency represented by the different parts of the sectorial angle. Here you are going to calculate the sectorial angle, that is the frequency over the total number of your frequency, or the sum of all the frequency times 360. That is how you calculate your sectorial angle. For example, if I choose to draw a pie chart of this one, I will add all this number of students together. Okay, so when I add all this number of students together, that will be my sum of the frequency. Then I will then start either from 70, it will now be 70 over the sum times 360. So that is how you calculate for your pie chart. So let's look at example of pie charts for the information below. These are the subjects and these are the number of students participated for each subject. For mathematics, 140 students participated, English 80 participated, CCA 50 participated, and French 70 students participated. So now what is the total number of the students that participated? We have 340 total number of students participating in all the subjects. Alright, that is our N. So now I've already put this in a tabular form. This is the number of the students. So now we want to calculate for the sectorial angle. I told you that we have the formula to be what? F over what? Over N times 360, which is this frequency over sum of all the frequency. Alright. So now it will be what? 140 over 340. When you sum this together, it gives you 340. So we have 140 over 340 times this 360 angle at a point. That is 140 over 360 is a section out of what? Out of 360, and that is 148.2 degree. For English, 80 over 340 times 360. For CCA, 50 over 340 times 360. And for French, 70 over 340 times 360. So when you divide these two, it gives you all the value. This value is what we refer to as the sectorial angle, and that is what we are going to use to draw our pie chart. Wow. So this is our own pie chart. Now, if you want to draw your own, you use your protractor and your compass. Construct a big circle and use your protractor to divide them into different sectorial angles. So this is an example of a pie chart, and this is how I expect your pie chart to look like. Make it neatly. Okay, so this is assignment 4. That can be gotten on your exercise 22.4, number 356. Is on page 298 of your book 1 new concepts. Thank you for listening. Please try as much as possible, do your assignments and submit them at the required mail.